Welcome to Lesson 3 of Section 1 in Unit 7. In Lesson 1 of Section 1, you had a separate introduction to each of the three measures of central tendency. In Lesson 3, we will continue our study of mean, median, and mode, but we will now look at these averages for the same set of data to see how they compare, and to ultimately determine which measure of central tendency best represents a given data set. Mean, median, and mode are three measures of central tendency, three types of averages. It is a number intended to best represent the values contained in a data set. And thus far, we have calculated the three measures of central tendency individually for different sets of data. What if we calculate all three averages for the same set of data? Will the three measures of central tendency have the same value? Will they be different? I wonder. Here's an example. The table indicates the snowfall in Rigolette, Newfoundland and Labrador on selected days during the winter of 2019. On January 10th, for instance, it was recorded 24 centimeters of snowfall. Our task, we're going to calculate the mean, median, and mode for the amount of snowfall that fell on those days. Let's first have a look at the mean. Our algorithm for calculating the mean is to add all of the data values in our data set and then divide by the number of pieces of data. In our case, we will add 24 plus 18 plus 6, 10, 15, 18, 22, 35, 10, 21, 12, and 32. And the number of days that we recorded this snowfall, there were 12. So we divide by 12. Using your calculator, if you wish, if you were to add those amounts of snowfall found in the numerator, it would total 223. We then divide by 12. That will be approximately, notice the symbol that I've used here for approximately, 18.58, and our unit here, centimeters. I could also write approximately as two squiggles and then 18.58. We have calculated the mean to be 18 and 58 hundredths. Let's now have a look at the median. Our median is determined by, first of all, organizing our data from least to greatest, or greatest to least. We're going to do least to greatest. 6, 10, 10, 12, 15, 18, another 18, 21, 22, 24, 32, and a 35. That gives us 12 pieces of data, which is an even number. We recall when finding the median for an even number of data, we will have two middle pieces to consider. I can group my first 5 and I can group the final 5. That then leaves two 18s in the middle. And that should immediately tell you that your median here is indeed 18 centimeters. If you were to carry through the process that I introduced you to of finding the mean of those two middle pieces, you would again get 18. And last but not least, our mode. If you recall, for the mode, we are looking for the piece of data that occurs the most. If I return to the list where I put the data values in order from least to greatest, I see that there are two 10s, there are two 18s, and those are the only data values that repeat themselves. What that implies then is we have two modes, 10 centimeters and 18 centimeters. Having found all three measures of central tendency, I'd like for us to have a close look at what we came up with. Our mean, approximately 18.58 centimeters. Our median, 18 centimeters. And our mode, we had a 10 centimeters and an 18 centimeters. Our values here, are they all identical? No, they're not. But what I do recognize is that 18.58 and 18 and another 18, we do have three values that either are close to 18 or are exactly 18. If I had to choose a number to best represent the average amount of snowfall, I think I would pick 18 centimeters. I would like you to now proceed to the next video in this lesson.